Hello. Today, our group will be presenting Google Play Store rating prediction. So what our problem overview and motivation. So our problem is what makes an app highly rated. In order to find the solution, we're going to use features such as category, reviews, and size to predict the rating. We also want to find the optimal model used to predict app ratings. So app developers can use the results to optimize their applications, including optimizing the size, price, and type in order for their apps to get a higher rating.
So our data set is the Google Play Store apps data set. There are 9,660 observations, and there are our target variable is the rating, which is a numerical variable, and there are in total 12 features, including like review, size, installs, and etc. So our pre-processing includes label encoding. We use sklearn pre-processing label encoder, and we also use regular expressions to convert the strings in the version and size into numerical values, and we also normalized using the standard scaler for some of our features. And then we also added categorical versions of our target feature, which are showed on the graph, on the picture. And we also noticed like there are some features like last updated and current version that are less relevant to our prediction. So we just dropped those. Next slide.
So since our original target value are continuous value, the first model we used is linear regression. First, we use a Pearson correlation matrix to find a limited features with high correlations. So on the top right graph, we can notice that installs and reviews, genres and category, both pairs have very high correlations. So we get rid of like one of each pair, and then we just correlate the raised features to the label and found that all of them like have relatively similar correlation. So we just keep all of them. And then we use a Lasso CV to find the optimal alpha. And turns out like alpha equals 0 is the best. So we just use the regular linear regression, and the MAC we get now is about 0.25. The second model we use is random forest regressor. And first we use the randomized search CV to like get a range of hyperparameters. And then we just focus on that like small groups of hyperparameters. And then we apply grid search CV to find the optimal hyperparameters combination. And the MAC for now is 0.21 for this model.
So for the categorical target feature, the first model we use is KNN classifier, and we trained 3 KNN models on different rating increments, as shown on the right side. We did it. There's one for increments of 1, increments of 0.5, and increments of 0.2. For the hyperparameter tuning, we use grid search CV to find the optimal hyperparameters, and we use accuracy score to compute the final accuracy, and the performance is shown below, which is 0.699, which is not very good. And the second model we use is support vector classifier, and we did the same thing as we did with the KNN. And the preliminary result we get is an accuracy of 0.788, which is still not as good as expected. So finally,
we can conclude with some preliminary results. And as we previously presented, for the regression models, random forests perform better than linear regression. And for the classifying models, support vector classifier perform better compared to KNN. And this is the results we have so far.